The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Test 3, problem number 10. It says, a weight suspended from an ideal spring oscillates up and down. If the amplitude of the oscillation is doubled, the period will what? Okay, so this is another conceptual problem. You look at the equation, but there's no numbers, so it's all about understanding the theory of it. So, you have a spring, and you have a weight, okay? And it's going up and down, so it goes up and down, spring. You can imagine that. Now, we're looking for, what are we looking for? The amplitude of the oscillations is doubled, so we have, this is the amplitude right here. If all of a sudden we have double the amplitude, it's going to go a lot higher and a lot higher and a lot lower. So that means that it'll probably be up here and down there. Okay? So what happens to the period? We're looking for, if that happens, then what happens to the period? Okay? So what we need to do is figure out how the two relate. Period, the time period of it to go from it to go up, down, and then back to the center is equal to 1 over frequency. Okay? Need to remember that. Now, another type of equation that the period has is that it has 2 pi root m over k for a spring. This is for a spring. This is just in general for waves for simple harmonic motion. Simple harmonic motion includes springs and waves. So this is just a general formula. This is for springs. Okay? That's for springs. So, does this have anything dealing with amplitude yet? No. So how can we get to that? Maybe if we look for what equations have amplitude in it. Alright, what equation has amplitude in it? The equation that has amplitude in it is for xm cosine of omega t plus phi. Okay? This is the amplitude. Okay? Amplitude. That's the distance, that's the x distance that it maximum achieves. Is there any relation between this and this? Any relationship? Is there anything going on? Nope. There is no relation between the two. So that means they don't relate. If the amplitude is doubled, then the time period remains the same. Messing with the amplitude does nothing on the time period. And it kind of makes sense if you think about it, if you think of a real life scenario. You have slinky, right? And you stretch out the slinky, or you let it fall, and then you stretch it out, and it goes up, down, up, down, up, down. You stretch it out farther, it goes up, down, up, down, up, down. But it doesn't really change how fast it is. I mean, how fast it goes, it reaches the top and the bottom. It goes faster going up and going down, but the time period that it takes to finish the oscillation is the same, despite the amplitude. They have no relation.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.